Today we're going to do something a little different and let everyone take a peek at our QC room. This room is where every headphone goes through for quality control, and every headphone is measured and tested just prior to shipping. But more importantly, we also do R&D in here in terms of measurements and seeing how all kinds of changes in the headphone design affect the sound and the measurements. And it's important to know that we put the two together. So what we've done is we've assembled what's currently considered some of the best test gear for measuring headphones on the planet. We're using the 5128 head by Brüel Kjær. I shorten it and call it B&K. It's the same test head that Jude from Headphone uses, and there are more and more manufacturers that are moving into this new standard, which is going to slowly replace whatever the old standards were. And the cool thing about this head is it's supposedly accurate to full range of audibility from 20 hertz or below 20 hertz to 20 kilohertz, where the old standards were usually 13, 14 kilohertz, even then was shady in terms of the results. So anyway, this head is capable of doing very finite measurements of headphones, IEMs, etc. And along with that, we've got the audio precision, the APX 517, which is the electronics that goes with the head. So it's a very low noise amplifier, mic preamp, etc. It interfaces to the computer. So the computer has the software in it that runs the APX 517, which plugs into the head. The head has two calibrated microphones in each ear. They actually simulated the shape of the ears. And the interior is all the current best there is to mimic the human head, which is pretty cool. So in talking about something like this dummy head, which isn't so dumb because it's technically advanced in terms of measurements, we prefer to use the shape of a head to measure. And in fact, it turns out you'll have way more accurate results using that, particularly because something like on our Diana, all our headphones, we have sculpted and shaped ear pads. They're not flat. They vary in depth and shape to fit the human head, which is what they should do because they're being worn by humans. So when you go to measure these, if you're using something that has a flat plate, for example, like a lot of the older test gear or the lower cost test gear does, our headphones won't interface to it well. You won't get a good seal, and therefore you're not going to get a good measurement. So, rather than fight that battle, it's way preferred to have a head-shaped measurement device for headphones. And of course, if you're measuring IEMs nowadays, which we're not doing just yet, then you'd want as close to possible as the interior of a human ear as possible, right? In order to really see what the actual frequency response and what's going on in the ear canal with an IEM. And again, this would be the head to use for that. So this is really something that most manufacturers should be looking at if they don't already have. Also, considering all that, not only do we have electronics, of course, our setup has a full online UPS. It's always running on generated power, so we're trying to reduce the noise as much as possible in the system. Short cable runs, really well-made cables, well-shielded cables. The computer, we built the computer in-house just to do measurements. Very oversized, low-noise power supply. Everything was done here to make sure that our test set isn't introducing any anomalies. And that's something else we need to talk about too, is the room and the acoustics, which we'll get into in a little bit. So the simplest thing to measure on a setup like this would be frequency response. So we can put a headphone on the test head, and in this case I've got a show demo Dyna TC, I believe, on the test head, and it's sitting here, and I placed it just so-so. And I hit start. Basically, I'll do it here to show you. We'll hit start. So we did a short sweep, and we end up with this as a curve. Now, something I want to show you, which is kind of important, is that when you get into measurements like this, we measure our headphones all day long. So we've got experience with making tens of thousands of measurements. But if you don't, and you're measuring foreign headphones or different headphones all the time, there needs to be some time taken to set the headphone. And even though we've made all these measurements over time, there still needs to be a methodology to setting a headphone on the head. And I'll give you an example of that. I'll take this headphone, the same headphone, it's on the head, and I'm just gonna move the ear pads just slightly, maybe an 1/8 inch forward, okay? And I'll have the computer do the same thing, sweep it, and let's just see what the results are on this one. And we'll narrow it down to the same one channel so it's not so confusing. So you can see where the red line and the brown line differ dramatically, particularly in the higher freaks, anything above about 1 kilohertz or so. And that was simply from me moving the headphone on the test head. All right, which one of these is right? Well, probably neither, because I haven't taken the time to go through and eliminate the problems here. And some of the things like these real sharp dips in the freak response here, that's a problem with placement. Those are acoustic anomalies between the head and the driver, and you need to get position the drivers just right so that goes away. That shouldn't be there typically. So bottom line is you could see that by moving the headphone on the test head, you can pretty much vary the results any way you want. For example, let's say I don't get a good seal, all right? Like I don't have a good seal on one channel, all right? So I purposely broke seal on the head on one channel. We'll measure it. Now you see what happens to the bass response here on that one channel. Let me narrow this down so it doesn't look so crowded. But now because the headphone, the one channel headphone does not have a seal, the bass response drops off rapidly and you get this hump in the bass. This is around 60, 70 hertz it's happening right now. So that is a telltale sign that you don't have proper seal to the test set. And anyone who does measurements would look at that and go, oh, I've got to readjust the headphone to the test set so that should be level. You could have a break in seal because the ear pad's not set properly on the headphone, and anything that leaves a gap will cause this to occur. And in listening subjectively, sometimes that sounds good, but when you're measuring, you're actually trying to measure a device to see what the actual transducer is doing, that's not the result you want. So you could see how just by moving the head about, how you get various results. One of the reasons we have this booth that the head is in is just for that. We can actually close the door. It's an isolation booth for sound. It drops the ambient noise by about 25 dB or so. I know a lot of people, the dB thing and the numbers don't mean anything, and even if I say 300, 3,000 times different. So we figure we're going to show you with a microphone. You're going to hear the sound in the room, and you're going to hear the sound in the booth. So we set up a Neumann microphone here, which is beautiful for vocals. It's going to record the ambient sound in this room with nothing going on, just me sitting here. Then we're going to take it and we're going to put it into the booth, close the door, and you're going to hear what the booth sounds like. All right, so here's the test with just the microphone. Okay, now we'll put the microphone in the booth. So typically when we're measuring things like distortion, where you can't possibly measure distortion in a room because the room itself is introducing noise into measurements, and you also don't know if your frequency response is correct either, because you could be picking up abnormalities just with traffic, with whatever, you don't know. So to get consistent measurements that are always going to be not of your environment, but of the unit under test, you close the door, it seals it in, and that is the quietest it gets in there. And there's a ton of absorption in there. There's isolation on the floor for low frequency isolation. So bottom line, this isn't the best you can do. Real companies that have a lot of money and can spend millions on this will have just really nice rooms that are floating on springs above the floor. They'll have, they're just custom made with huge foam panels and peaks and, a real anechoic chamber, so to speak, that really is just dead quiet at all frequencies. But for the purpose of what we're doing here with headphones, this is more than adequate. All right, so not to make this video too long, but I think we're going to break this up into a couple segments. So next video, we will talk about distortion. Everybody's favorite word, like it's some thing that if it happens to you, you're dead. And we'll talk about that in the next video. Peace.